Good day to you, sir. We are the Group 3, and here is our topic. Our topic will be the sextant altitude by the stars and the planets. And so here is the course, which is the Mtec 101, under finals period, week 1, session 1, and also, as I had said, our topic will be the sextant altitude by the stars and by the planets. And also here are the members. So I introduce myself as Christian Gabriel Burgos Lopez, to be followed by Kadivida Joel and also Vance Audrey Cañete. Our learning outcome. At the end of the session, the students shall be able to determine the sextant altitude by the stars and also by the planets. And so without further ado, let us start. So first thing first, what is sextant? So the sextant is an essential tool for celestial navigation, and it is also used to measure the angle between the horizon and an invisible or visible object, or two more objects at the sea. Also, the sextant was also designed to find the longitude by measuring the angular distance between the moon and also by the nearby star. Also, the sextant was also used on land and to find the latitude at the sea. A sextant is similar to an octant, but it is more powerful and more precise. Thank you.
Good day to each and everyone. I'm Cadet Vance Audrey Cañete, and now we'll be talking about sextant terminologies. So, sextant altitude is the altitude of a celestial body measured by a sextant. It is the angle measured in a vertical plane between the horizon and a celestial body. Height of eye, or DIP, is the distance from your eyes to the ground or to the water surface. Index error is a correctable error in the reading of the sextant resulted when the horizon and index mirror are not parallel. So here is an example problem in getting an altitude of a star. So find the altitude of star Rigel on 16th of December 2008 when sextant altitude was 30 degrees 28 minutes, height of eye is 10.5 meters, and index error is 0.3 on the arc. So for the solution, our sextant altitude, or HS, is already given, which is 30 degrees and 28 minutes, as well as our index error is given, 0.3. So subtracting them, we could get your observed altitude, which is 30 degrees 27.3 minutes. So for our DIP, or the height of eye, since the nautical almanac, the given information by the nautical almanac is in feet and the given was in meters, so we should convert meters into feet to get our height of eye. So 10.5 meters times 3.28 feet would equal to 34.44 feet. So in the height of eye column, 34.4 feet as marked in the height of eye column would equate to 5.7 minutes. So we would subtract it from our observed altitude, where we can get our apparent altitude, which is 30 degrees 21.6 minutes. So for the total correction, we could get it in the nautical almanac. So since we have the apparent altitude of 30 degrees 21.6 minutes, we could see what it would equate in the nautical almanac. So 30 degrees 21.6 minutes as marked in the nautical almanac would equate to 1.7. So subtracting it from our apparent altitude, we could get our true altitude, which is 30 degrees 19.9 minutes. So thank you so much. Example number 2 would be reported by Cadet Kadipida.
Find the sextant altitude of planet Mars on December 20, 2004, when sextant altitude was 50 degrees 17 minutes. Height of eye was 8.5 meters. And index error 0.4 of the arc. Solution: sextant altitude given 50 degrees 17 minutes. Index error given 0.4 of the arc. Since this is off the arc, so we add these two, and we have observed altitude of 50 degrees 17.4 minutes. And then DIP, or height of the eye. Since the given height of the eye is in meters, first we can do is to convert meters into feet. So 8.5 meters times 3.28 feet, we have 27.88 feet. Next is find this value in nautical almanac in DIP, or in height of the eye feet column. So as we can see in the nautical almanac, 27.88 has an equivalent of 5.1 DIP minus 5.1. So observed altitude minus height of the eye 5.5 equals 50 degrees 12.3 minutes, our apparent altitude. Since planet Mars has a total correction, so we correct this from apparent altitude. So as we can see in the nautical almanac, look first the value of your apparent altitude. Since we have the apparent altitude of 50 degrees, so we look this value in the nautical almanac, and we found that has a correction of 0.8 minus 0.8. So we subtract it, and we have a apparent altitude 50 degrees 11.5 minutes. And as we can see, this is a planet Mars, and also has a additional correction. So the given problem is the sighting of sextant is on December 20, 2004. So we have additional correction of plus 0.1. As you can see, the nautical almanac table given, and we have, so since this is plus, we got our true altitude of 50 degrees 11.6 minutes. This is our true altitude of planet Mars.